Okay, the next step now would be, right now we have the lights coming down, the red lights coming down on each column, and the green lights going up on each column. So now I guess the next logical step would be, in the development of this game, would be to put in the inputs. And so what I'll have here is I'll have two switches on this side here and a firing button on this side here. And the left switch here will allow the left column to come on so that I can use the firing button to send green lights up on the left hand side. And then the right button would come on to turn the right column on to send the green lights up on the firing button activity. Now, at the same time, I also want to have it so that only one column can be on at a time. So that means if both inputs on these two switches here come in at the same time, then they will turn each other off so that there is no outputs at all. So that would make the game more better to play that way, more challenging to play. Therefore, what's needed is the logical solutions now to attain that kind of outputs. And that's what we're going to look at next. Okay, so let's see if we can draw this up now, how we want to make this next circuitry. Let's represent this box here being the left column and the right column. And those are the columns going up for the lights, for the green lights. Now we need to have a way that we have two buttons here. Okay, so we have our two buttons and our firing button over here. So now we need a way that we can be able to turn on one side at a time and hit the firing button and have that side be activated only. When the fire button goes on, the lights go up, and then the same thing on the right side, and then they turn each other off as well when they're both simultaneously put together. So let's think this through here. If we had an AND gate, for starters, if we put an AND gate here and an AND gate here, outputs go into the columns, and we tied one input of one AND gate to the input of the next AND gate, and then took that to a common firing button here, and then we took this here input switch here and this input switch here, and that would take care of that at that point right there. Okay, so what that allows us to do is that allows us to direct the data input from the firing button and the directional switch to each column as it's called for. But now we have one more logic function to fulfill here, and that is when both of these buttons are on simultaneously, we want 0 outputs on both of these AND gates. So we know that if one input, there's an output, that would be an OR gate, and if there's both inputs are high, then it would turn off completely, so that would be an exclusive OR gate. So if we made an exclusive OR gate here, and if we tie the input of one of these exclusive OR gates input to an input switch here, same thing here, what would happen then is when this button goes down high here, it goes high here, the output will fan into this one, and it will fan out to that one. So what happens is when there's an input on one switch, there's an input going through the exclusive OR gate, there's an output that goes to both inputs of both AND gates, and then the thing that determines which AND gate comes on would be the firing button, because that would give you the third input. So what we have here then is we have an exclusive OR gate whose output will fan into an input of each AND gate, and then we'll have the input of the exclusive OR gate hooked to the buttons over here, and then we will do this setup here. Let's see how that works now with the circuitry. The circuitry part, now here's how I do my AND gates. If I'm going to have a 3-input AND gate, it's going to look like this. I'm going to have an NPN transistor whose collector is connected to the positive side of the battery. Then I'm going to have an emitter resistor to ground. Then I'm going to have a base bias resistor to the positive side of the battery. The output will come off the emitter here, and I will have 3 diodes connected in such a way that they are separating the inputs, and then each diode will be grounded through a 2K ohm resistor. The inputs now to this AND gate will be in between the diode and the resistor. That would be input 1, input 2, input 3. That's how I do my AND gates. What happens here is that these diodes are grounded to the base of the transistor through the 2 k ohm resistors. When these here go positive here, it draws current away from the diodes, therefore it draws current away from the negative voltage away from the base of the transistor, causing the base to rise high through its base bias resistor here, turn it on, and then we have an output through the collector emitter output. And of course this here is to keep the a voltage drop across there so that we don't have any kind of erroneous outputs when there's no inputs, proper inputs. So that's how I do the AND gates. Now comes the exclusive OR gates. Now how am I going to do an exclusive OR gate? I think the way I'm going to do it is this. I'm going to use an NPN transistor. Again, emitters being the output. The emitters being the output. Okay. Collectors being directly in. But I think what we have to do this now is that when there's an input to one transistor here, okay, this would be the input to one side of the exclusive OR gate. At the same time, it's going to turn on the base of another transistor, which is going to be an NPN transistor connected its emitter to ground, and that transistor is going to cross-couple into the base of the opposing transistor that it's mirroring. And the same thing this way here, they'll be cross-coupled that way there, so that when one input comes in, there's an output through that transistor here. But if both inputs come in, then the succeeding transistors on both bases will turn each other off by cross-coupling. I'll draw the whole thing and we'll look at it. Okay, so now what we have here right now is this is the outputs. This would be output A, and this would be output B. This would be input A and input B, and that would be here. Input A, input B, and then the output here would be A and B together. So actually, yeah, that's right, there's an OR gate. So A and B is actually one output coming out of here, as you can see. Okay, that's an OR gate. Now, here's what we got. If input A goes high, this transistor comes on and draws a high output. If input B comes on, it draws a high output. So right now we have an OR gate. But we want to make this into an exclusive OR gate, so that's why we put these transistors here now. So that when input A goes high, it also turns on this transistor, which is emitter grounded, and its collector now flows negative into the base of the opposing transistor here. And then we do the same thing here. When this here transistor here is cross-coupled now to the base of this transistor here, then what happens is this transistor here turns the base of this off, and this transistor here turns the base of this off. So if B goes high, this goes low because the collector goes low to there. If this goes high, this goes high, this goes high and high. So what we have here is cross-coupling. So here's what happens now. When they both go high, then both of these transistors come on, and when they come on, they turn off the output transistors. And that cross-coupling produces the exclusive part of the OR gate of this here. So we need to build this circuitry here, tie it to two of these AND gates, 3-input AND gates, and then put that with the circuit here and see what we come up with. Run down here in the circuitry. This area here is the exclusive OR gate. These are the two AND gates, 3 inputs each. And because this circuitry here needs negative inputs in order to make the outputs happen, I had to put 2 inverters. All they were just 2 NPN transistors. I have the switches. And so let's go ahead and put this to a test here now. What we're going to do is we're going to demonstrate now the exclusive OR function of this. First of all, what we're going to do is this is the left column for the left lights going up, and this button here is for the right column, and this is the fire button. If I hit any of the position buttons right here, this one, nothing happens up here until I hit the fire button. When I hit the fire button, then the light goes up. I don't know if you've seen it or not. Let's see if you can see that. I hit the fire button. Okay, now, if I hit the right button over here now, and I hit the fire button, the right column goes up. So let's see if we can get a better view here of what's going on here. The buttons and the lights together here. So we can get this thing. All right, here we go. Now, if I hit the left, what I'm going to do is only hit the left button here and the fire button, and I'm going to start sending signals up on there. You see it going up? Everything on view here. Here we go. I think, well, can you see everything now? Let's see, how's that? If I hit the right side and the fire button, the right column goes up. Now here we go to the exclusive OR function. If I hit the left and the right both together, and I hit the fire button, nothing happens. If I let go of the right side, now the left side goes on. If I put them both down again, nothing. I let go of the left side, and now we have the right side working. So the exclusive OR gate is working. So I can be firing on the left-hand side here, and then need to go on the right-hand side and forget to put the left-hand side up, and I'll cancel everything. But I let go of the left-hand side, and now I get the right side working. So I can only work one side at a time only. I can only work one side at a time. All right, there he is.